Hi, in this video we're going to look at some basic derivative rules, and we're going to focus in particular on contrasting between when to use the power rule and when to use the rule for the exponential function. So in the box over here on the right of the screen you see the rules that we have learned so far. So all of these come from the definition of the derivative. If we apply that definition, the limit as h approaches 0 of f of x plus h minus f of x all over h to these basic functions, this is what we get. So we have three basic function types. We know derivative of a constant is 0. We have power rule, so derivative of x to a constant power, that's the bring down the exponent subtract 1 rule. A lot of students tend to remember. And then the derivative of the natural exponential function is its own derivative. Then we have a couple of rules for combining functions. So two rules here, one for adding functions. The derivative of a sum of two functions is the sum of the derivatives. And then the constant multiple rule. So if I have a constant times a function, that constant just comes along times the derivative of the function. Again, all of those come from that definition applied to these functions. But now that we've applied that definition to some particular functions, we don't have to do that every time. We can memorize some of these rules and apply them to these examples here. Okay, so when I look at these examples here, one of the first things that I should pay attention to is where are the terms. So I've got these addition and subtraction signs separating this first one into three terms. So the fourth rule in the box over here about derivatives of sums of functions basically tells us that if I can separate this into terms that are added or subtracted, remember we can think about subtraction as adding a negative, that I can essentially differentiate each term separately. All right, and then in the first term here, I'm going to notice that I have a constant times a function. So I have a constant, my constant is 3, and then times that exponential function e to the x. So I'm going to be using all of these rules really in this first example, just kind of in different parts of the problem. All right, so when I find the derivative, I want to be sure to label that as y prime or dy dx. That's not the same as the original function, so I need to distinguish between the original function and its derivative. All right, and then for this first term, I'm going to use the rule for a constant multiple of a function that says the derivative of a constant times the function is just that constant times the derivative. So that 3 is going to just come along on that first term. And then the derivative of e to the x, that's just e to the x. That function is its own derivative. Okay, and that's the first term. So now I'm going on to the second term. I'm using the rule about sums of functions here. So I'm just going through term by term. On the next term, the constant 5 will just come along. And then when I apply the power rule, that is the bring down the exponent subtract 1 rule for x squared. That's where I have x to a power of n. I'm going to bring down that exponent and subtract 1, so I'll have 2x to the 2 minus 1 is 1. And then the last term here, I'll have plus, and then the derivative of negative 4, derivative of a constant function is 0. So the better you get at these, the more likely you are to just write down this derivative and simplify it all at the same time without having to write out some steps, and I am fine with that, but not everybody is quite there yet, so I kind of wrote out a step there in the middle. So here's the simplified version. The big deal important thing about that example I did is that you're paying attention to where your variables are. In the first term, the variable's in the exponent, so I'm using the rule for the exponential function derivative. In the second term, my variable's in the base, so I'm using the rule for the power function derivative where I've got the variable x in the base. That's the big deal on these. Pay attention to where the variables are. Okay, in the next example here, I'm going to scroll up just a little bit here. In the next example here, we've got a whole bunch of terms, so we're going to kind of pay attention to where the addition and subtractions are. So we're going to think about separating this term by term. And then within each term, I'm going to pay attention to where the variables are. All right, so one of the things that you might notice in the first term is that there are no variables. So that first term is really just a constant term, 2 times e. E is just a constant. In the second term, my variable is in the exponent. That's an exponential function term there. So I'm going to be using constant times exponential function on that term. My next term here is just a constant times x. I can think about that as x to the 1, but my variable's in the base on that one, so that one will be power rule. My next term is also power rule. I've got an e there, but that e is just a constant out front. So constant times power. And then this last term here, we might want to rewrite that as a different form. So one thing that can be helpful here is recognizing that that is the same thing as e times x to the negative 2. Okay, I'm going to rewrite the whole original function and label this as y. So I'm just going to write that as 2e. I'm just going to modify a couple of things here to make it a little easier to x to the 1 on that third term plus e times x squared, and then the last term e times x to the negative 2. All right, now when I take the derivative, I'm going to label this as the derivative. One thing that's important to notice here is I'm taking the derivative of the whole function all at once. Sometimes students try to take the derivatives of pieces of the function and then try to remember which pieces they've already taken the derivatives of and go back and take the derivatives of the others. That's a bad habit to get into, and technically what you're writing down in that middle step is just kind of nonsense anyway. All right, so again, that first term, that's just a constant, no variables in that first term, so the derivative of that constant term will be 0. On my second term, I have a constant times a function. That constant will just come along. That's that constant multiple rule, that last rule in the chart over there. And then derivative of e to the x is just itself, e to the x. On the next term, the constant will come along, and then I will do the bring down the exponent, subtract 1 rule on my power function here. That simplifies, so I'll maybe simplify that in the next step. My next term, I again have constant out front, constant times a function. In this case, the constant is e, so that e just comes along, and then the power rule, 2 times x to the 1, 2 minus 1 is 1. And then the same rule here on the last term, it's just that the exponent I'm bringing down is a negative 2. And then when I subtract 1, I have to be a little careful about that. Negative 2 minus 1 is negative 3. So making sure you're subtracting 1 instead of adding 1. And then we'll just go ahead and clean that up. So y prime equals, I don't really need to write the 0 term. So 2e to the x. This next term, x to the 0 is just 1. So this next term just simplifies all the way to 2. The next term I have e times 2x, or I might write that as 2ex. Make sure your x there is in the base times the 2e and not in the exponent. And then the last term here I could write as minus 2e x to the negative 3, or 2e to the x plus 2 plus 2e times x minus 2e over x cubed, if I want to write that last term back as a fraction as it originally was.